And this is question 9 of the June 2011 paper, paper 1, variant 2. And this is a functions question where the function f of x is equal to 3 minus 4 cos to the power of k x for 0 less than or equal to x less than or equal to pi. This is our domain, and k is a constant. Now in the first case, where k is equal to 2, the a part is find the range of f. Now I'm just going to make this full screen. It's easy to find the range of x as long as you graph the function. Graphing the function is important for trigonometric functions. If you want to find the range of it, you'll have to graph it. So the function that we have to graph is basically 3 minus 4 cos squared x. So first, let's take this step by step. Let's first graph cos x. Now cos x looks something like this. We have 1 over here, and we have pi by 2 and pi. So if we were to graph this, then we would get something like this. Where the maxima is at pi, because where the maxima is at 1, but the minima is at pi, because cos of 180 or pi is equal to minus 1, and minus 1 is below here. Now, if I clear this page, I hope you got this, let's graph the second part, that is cos squared x. Now how do we graph cos squared x? If we put our 1 over here, we put pi by 2, and we put pi, then we know that cos squared of 0 is 1. Cos squared of 90 or pi by 2 of 90 or pi by 2 is 0, and cos squared of pi, since cos of 180 is equal to minus 1, square root of that will equal to 1. So it comes back above over here. Now you see the difference between the previous graph and this graph. The previous graph had its minima down over here, but here this point has moved from here to here because of the cos squared. Now the third graph we want to graph is 4 cos squared x. Now how would 4 cos squared x look? I hope you've taken this down. I'll clear the page. Now I'll just graph 4 cos squared x. In 4 cos squared x, we'll graph it for the same points, pi by 2 and pi. Now we can say that 4 cos squared of 0 is not 1, but this time it's 4, because 4 into 1 is 4. So if we have 4 over here, we can put this point over here. Actually, it's at 0. We can put the 0 point over here. And now at pi by 2, it still remains 0. At pi, it's minus 1, so it becomes minus 4. But because it's cos squared of 180, it becomes plus 1. Plus 1 into 4 is plus 4. So it comes back up over here. You see that the minima of the previous graph remains the same, except the amplitude of this graph has increased. I'll just draw this again. My cursor has to come back. Something like that. Now, the fourth step is graphing minus 4 cos squared x. And I think you're way ahead of me on this. If I just erase this graph, I'll redraw the axis one more time. I think we'll need the negative axis over here. At 0, it will become not plus 4 but minus 4. So, and then at 9, it'll stay at 90, it'll stay 0, and at 180, it'll become minus 4 again. So the graph is inversed. It's intertwined. It's the x-axis acts as a mirror. Now, the final fifth step is 3 minus 4 cos squared x. Now, this 3 acts as something called a translator. When it's outside of this function, correct? It acts as a translator. That means it moves the graph along the y-axis. This 3. So, because it's plus 3, it moves the graph plus 3 above. So, it moves this graph 3 steps. So, 1, 2, 3. So, this point will become over here at 3, 90. This point will come at 1, 2, 3 will come over here, and this point will come over here. So the final graph will be this. So therefore you can say that the maxima is at this point, is at 3. We'll keep that. And the minima is at point minus 1. So therefore our range is from minus 1 to 3. I hope you see how I did that step by step. It's very important to do it that way. Every function you get, especially trigonometric functions. Okay, so I'll move on to the next part of the question. Let me just clear this page. So the next part of the question says, find the exact solutions of the equation f of x is equal to 1. Now in this case, our k is still equal to 2. So our f of x is still 3 minus 4 cos squared x. And since f of x has to equal to 1, our 3 minus 4 cos squared x has to equal to 1. Therefore, 4 cos squared x, this is a regular algebraic equation, is equal to 2. Cos squared x is equal to half. Cos x is equal to root of half, which is root 2 by 2. So x is just cos inverse of this. And we know that our x will equal to 45 degrees. Now, that's the answer to 9.1 part B. I'll just clear this page again. Hope you understood that. Now, in the part 2, it says in the case where k is equal to 1, so our function becomes f of x is equal to 3 minus 4 cos x. And now it tells us to sketch the graph. So let me make this full screen. I'll erase this page. Let's keep the function there so that we know how to do it. So we'll do the same method like we did for the first part. We draw the x-axis here, the y-axis here, and it says that the domain is just pi by 0 to pi. So I'll just put that on the x-axis. Now, we have to graph this in steps. First step is to graph it cos x. Second step, graph 4 cos x. Third step, graph minus 4 cos x. And fourth and final step, 3 minus 4 cos x. Now this acts as a translator again. So let me do this step by step. Cos x will just be, if this is 1, cos x will be just, there will be a point here, there will be a point over here, and there will be a point down here where this is minus 1. So it just will be like this. I'll just erase this page. That's cos x. So cos x we're done with. Now, if I erase this page, draw another set of axes. I draw pi by 2 and pi. Now 4 cos x is basically just a 4 amplitude. Everything is multiplied by 4. So since 0 multiplied by 4 is 0, this point remains the same over here. But at x equal to 0, it goes to 4 over here. I should be doing this with a different color. Let me just change the color. This point, it's over here. Here it stays the same at 0. And here it goes to minus 4. So the graph is just elongated. and that's 4 cos x. Let me clear the page. I hope you got that. Let me change the color. Now we're going to graph minus 4 cos squared x. It's pi by 2, pi, and minus 4 cos x. Everything will just be intertwined. So it'll be 4 here, minus 4 here. So at 0, it'll become minus 4. So let me just change the color. At pi by 2, it'll stay 0. At pi, it'll become 4 because minus 1 into minus 4 is 4. So the whole thing is reflected. Sorry, this didn't go through that point, but you get the idea. So now this is done. This is done. Now it's 3 minus 4 cos x. Let me just clear the page. Change the color. Now this is our final graph. So pay attention over here. You have to take the previous graphs and put them together. So if I plot pi by 2 here and pi here, I'm plotting only pi by 2 and pi because the domain says I should. Now remember our previous graph where here if it's minus 4 and here if it's plus 4. Our previous graph started from minus 4 and went to plus 4. This one, we have a plus 3 translator. So we want to move this up by 3. So 1, 2, 3. So this is 1 point. Here, we want to move this up by 3. 1, 2, 3. So here. And pi was originally over here. So we want to move this up by 3. And since I can't fit this, it goes at 7. So imagine this is 7, we put this here. 7 is somewhere up there. And now we can plot this. I'm plotting it here, but 7 is way up there. So you get the idea. This is the basic graph of 3 minus 4 cos x. Always start small and then go big. It'll really help things. I'll just clear this page and go to the last question. Actually, the last question requires us to have this graph. So let's keep this graph, and it says state with a reason whether f has an inverse. And what they mean by this question is within the domain given, does f have an inverse? Now there's a concrete way of knowing whether f has an inverse, and that is the horizontal line test. Let me just write that down. The horizontal line test. And the way that works is, through the graph that you've drawn, draw a horizontal line through any point of the graph. I'm drawing many, but you can draw one. And see how many points does your single horizontal line intercept the graph. If it intercepts the graph more than one time, that means it does not have an inverse. In our case here, the horizontal line intercepts the graph only once. Since I've drawn many, each horizontal line intercepts the graph only once. Therefore, this is a one-to-one function. And when a function is one-to-one, it automatically has an inverse. That's the simple guidelines. That's the simple test. Hope you understood this. If you have any questions, email me.